Good morning. My name is Marjorie Jean-Pierre, and I'm a Senior Director at the United States Energy Association. We are pleased that you're able to join us for our webinar on climate risk management, key lessons from modern power, key lessons from U.S. utilities, my apologies. This program is part of the Advancing Modern Power Through Utility Partnerships AMP-UP program, managed by the U.S. Energy Association and financed by the U.S. Agency for International Development. The goal of USDA is to convene, educate, and provide a nonpartisan forum for the energy industry internationally. USDA supports energy development by expanding access to safe, affordable, and sustainable energy in partnership with the US government. For over 30 years, USDA has collaborated with the US Agency for International Development to provide capacity building assistance to our overseas partners for increased energy security and access by conducting programs that encourage the sharing of global best practices and exposure to latest developments, including private sector engagement, market-based approaches to utility operations and management, implementation of regulations and environmental safeguards. And the U.S. Energy Association, in collaboration with a consortium of highly skilled organizations, will be managing a new initiative with USAID, the Advancing Modern Power Through Utility Partnerships AMP-UP program. The consortium is comprised of Arizona State University, MK Advisors, NRECA International, and Segura Consulting. The program was developed to introduce an innovative performance improvement model centered around peer-to-peer relationships and strong practitioner and stakeholder networks. The program will use the vast experiences and knowledge of a diverse consortium, as well as energy sector experts from around the world, to offer an unparalleled network of utility and energy sector expertise to support the global energy transition of the participating overseas partners. The consortium will work in collaboration with USAID and the overseas partners to identify long and short-term goals for country utility operations that encourage and support staff capability on new technology and innovations to deploy effective climate solutions. This webinar on climate risk management is being led by Segura Consulting and is presented under the AMP-UP Technology Webinar Series. The series will highlight current energy issues being discussed and implemented globally and will be led by each AMP-UP consortium member. We hope you will continue to join us for other webinars in the series. Again, thank you for attending, and I now have the pleasure of introducing Kristen Madler, Clean Energy Coordinator, Energy Division, Center for Environment. Center Environment, Energy and Infrastructure, EEI, Bureau for Development, Democracy and Innovation at the U.S. Agency for International Development. Kristen, thank you for joining us.
Thank you so much, Marjorie, and welcome. Thank you all for being here. Today, we're going to dive into climate risk and resilience planning for utilities. And this type of planning is essential to ensure electricity infrastructure is designed and operated in a way that accounts for the impacts of climate change, impacts that are already being felt and which continue to intensify in the future. And to prepare for climate risks, utilities must identify climate-related vulnerabilities within their systems and explore pathways to reduce and manage those vulnerabilities. Very few utilities have engaged in comprehensive climate resilience planning, and in cases where climate resilience planning has occurred, utilities often primarily focus on climate impacts such as storms and disregard more gradual changes like temperature change and sea level rise. So today we'll hear from utilities that are incorporating climate risk planning into their long-term planning processes. And we look forward to sharing approaches that demonstrate how two US utilities are assessing their unique risk exposure profiles, infrastructure costs, and preparing for extreme weather. Please stay tuned for more upcoming technical webinars from the AMP-UP program in the coming months. And I'll now pass the floor to Jonah Belser from Segura Consulting, and he'll tell you a bit more about today's webinar.
Thank you very much, Kristen, and thank you all for joining us. My name is Jonah Belser. I'm a senior associate at Segura Consulting, which is delivering this webinar through USAID's AMP-UP program. Kristen was just telling you a little bit about the cutting edge practices that the two utilities you'll be hearing from will be sharing with you, which include undertaking climate vulnerability assessments, or CVAs, as well as developing resilience and adaptation plans. You'll be hearing how both Con Edison and PG&E, two US-based utilities, are undertaking those and other climate risk management activities. The key here is that the utilities are going to be telling their own resilience stories, sharing not only the best practices that they've accumulated, but the challenges that they've encountered along the way. The goal is to both disseminate technical knowledge and to identify procedural lessons developing country utilities can consider in their own climate risk management work. We're going to begin with presentations from both of the utilities on their climate risk and resilience planning activities to date. That will be followed by a panel discussion between the utilities with time for question and answer with the audience. The microphones of all audience members are muted, but we'll open the chat menu for you to type questions to the panelists during the panel discussion. I hope that by listening to the presenters, you'll walk away with a greater understanding of climate risk management and maybe even apply some of the essential concepts and learnings to your own power systems. To get us started, it's my pleasure to introduce Nelson Yip and Charles Weimeister of Con Edison's Climate Risk and Resilience team. Nelson is the Director of Strategic Planning, where he's helping shape Con Edison's resilience plans and clean energy future strategy. Charles is the project manager who completed Con Ed's climate change vulnerability study in 2019 and established the climate change implementation plan for Con Ed in 2020. Nelson and Charlie, thank you very much for joining us, and over to you.
Hi, good morning, everyone. Thank you so much for the opportunity to present to the AMP-UP program and really share our climate resilience journey. As Jonah mentioned, my name is Nelson Yip, and I'm the Director of Climate Risk and Resilience at Con Edison in New York. First, I'd like to provide a short company overview. So if you could go to the next slide. Con Edison delivers electricity, gas, and steam to 10 million people in New York City and Westchester County. And we serve 44% of New York State's electricity needs. And now our electric system is one of the most reliable in the United States, and we provide natural gas to over 1 million customers and operate the largest steam distribution system in the United States. We are a coastal utility, and our service territory is 660 square miles. Now, advancing climate risk and resilience is not new to our company. We see it as an extension of our environmental and engineering excellence, and really our ability to build the grid of the future with our decarbonization efforts and providing a safe, reliable, and resilient energy system for our customers. Charlie, next slide. So it has been 10 years since Superstorm Sandy. Kristen mentioned how storms define companies. Well, the impact of this storm caused over 1 million customer outages, the most in our history. So we lost numerous parts of our infrastructure, including cables, feeders, transmission stations, and many parts of our infrastructure. However, our company's investments in the past decade, over $1 billion worth, have really helped to fortify our system after the storm and have prevented over 1 million weather-related outage as we've invested in increasing electric, gas, and steam resilience to sea level rise and storm surge, flooding, and heavy winds. Now, talking about the AMP-UP program and the need to share best practices, as an aftermath of post-Sandy, we've changed our mindset to think about how do we incorporate future climate data into the investments that we make. So next slide, Charlie. So this is a look at the progress of Con Edison's climate adaptation work and also our resilience journey. We partnered in the aftermath of Superstorm Sandy on a climate change study with Columbia University to really think about our vulnerabilities, our modeling scenarios for various hazards, and how does it affect our electric, gas, and steam systems. Once we understand how, as Charlie will talk to you about, localizing the global climate data, we worked to incorporate and think about the vulnerabilities to our system. And what we did was we took our 2018 system and fast forwarded through time to 2018, 2100. We understood what the climate risks are. And then after understanding what the climate risks are, how do we incorporate it into our policies, procedures, and also engineering designs? And that was through our climate change implementation plan. As an organic journey, we had to continue to incorporate climate resilience investments as part of the way we design and operate. And how do we incorporate it into our rate cases and long-term planning? Now, recently in New York State, There is new legislation for all New York State electric utilities to come up with vulnerability studies and long-term 10 and 20-year resilience plans. I'll turn it over to Charlie for him to describe what we did to really bring this together, how we started, and get to where we are today. Charlie?
Yes, good morning, everybody, or good afternoon to some, I guess. So we started this back in 2017, actually. And as Nelson said, events always drive our movement going forward on climate impacts. So we started in 2017. We recognized those areas that were most impactful to us: temperature, precipitation, sea level rise. These are based on historical events triggering, measures that we had to put in place in response to those events. So we identified that with our engineers, and then we had to go through. And the next thing we really had to work with is how do we pull this information together on what the climate science is telling us is the future. And as Nelson said, we took our system and wanted to put it out into that future and say, as it stands, where are the weak spots and under what conditions do we have to concern ourselves? So we had to work with academics. So we worked with Columbia University to try and work the climate science and pull that into our business. The thing with that is academics tend to talk about it's highly likely, very likely, more likely, not less likely. And we couldn't deal with that. Our engineers need some sort of reference framework because we already have that in our specs. When temperatures go over 95 degrees, when the ambient temperature goes over 86 degrees, we need to know what the likelihood of that happening and when it will happen. So we had to work with Columbia, and our group, Nelson and I, acted as the translators to work with the climate science, get to understand what they can and cannot provide us in terms of data, get it to our engineers, get an understanding how that impacted their designs, their specs, their procedures, their processes. But key to this was the fact that this all grew from Sandy. And after Sandy, we had a collaborative group that included external stakeholders that helped us with deciding post Sandy what work we could do cost effectively and not overburden our customers and yet create as much reliability as possible. And as Nelson said, we've already reduced the number of outages that we've could have encountered over the past 10 years. But it was key to have them involved all the way through the process. And it was called a working group because we were really doing the work, and it really was just to keep them informed, keep them understanding why we're making certain decisions so that we can get some feedback from them. And in some cases, we had special meetings with different groups, like New York City had their own plan. They were looking at their own climate study that they were going through. And we wanted to make sure that we were coordinated in how we were going to approach this, because nobody wants to be too far ahead or too far behind in terms of responses to climate change when you have overlapping interests, right? Flooding interests for us are equal for any building in the city, as well as for us and our assets. So we want to make sure that everybody is thinking the same way. A lot of that was worked with a consultant because it was our first time. We needed help. What we're trying to do now is we're trying to incorporate that further into our system. So Nelson and I are heading up a group right now. It's our Climate Risk and Resilience group. We have an executive committee within the organization that was formed. These are VPs in all the key areas that are impacted. So they give us input. We give them an understanding where climate science is going, how things are changing, what guidelines that we've put in place may have to be adjusted. And we're trying to build that out a little bit further so that it's embedded in our organization and we don't have to rely as much on consulting to do this. We still need, until the technology is up, we still need like a university or somebody to pull the climate data together for us. Although there's models that are being built that we're starting to look at that maybe could be incorporated inside Con Edison. Now, as we said, we had looked at several different pathways. And when we first started, because it was new to us, we took two different pathways to look at. One was the RCP 4.5, and I'm hoping everybody here is familiar with these, and the RCP 8.5. Using those as boundary layers to try and determine if we're going to have problems in our system at the 4.5 level, we really didn't need to make changes quickly. But if the 8.5 is when we got to the level that we had issues, there was a better understanding. So we worked with those models to come up with the impacts, the vulnerabilities, and then some assessments of how we would adapt to those different levels. Eventually, you have to pick something to design to. So for us, we took a hard look at the data. And again, having the working group involved helped us to explain the risk tolerance that we were trying to look for, what other entities like the city, like the Metropolitan Transportation Authority, the New York Port Authority, what they were looking at in terms of how risk tolerant they wanted to be. And also taking a look at the standards that we had put in place after Sandy. A perfect example here is we had established a sea level rise standard of 1 foot of sea level rise. So we anticipated that we'd have the 100-year storm, we'd have add on top of that 1 foot of sea level rise, and then as a safety factor, we had another 2 feet of freeboard. That was our design after Sandy, and that's held us now that we've got information from the science that now shows us that out to 2040, that was going to be a solid way of approaching it. And it was good that we didn't do more, because earlier on, it was $1 billion expenditure back in 2016. But you didn't want to overspend. Again, you didn't want to overburden your customers to get there. So we found out that this is good until 2040. New science is starting to show that there's not much difference to that right now, the new data that we're getting. So we're still good with that, but we had to make a decision that after 2040, we needed to add more safety factor onto our designs. So now anything that goes past 2040, any asset that's going to live out there and have to operate in that period, now has to be at an additional 2 feet of sea level. So you got 3 feet of sea level rise plus that 2 feet of freeboard. So we call it FEMA plus 5. It's the FEMA 100-year flood plus this 3 feet and 2 feet. That's what has to be in the design going forward. So now that we have this, we've created a guideline, climate change planning and design guideline for the engineers. It includes tables of calculations for temperature, for precipitation, and items like this with sea level rise and how to adapt to the sea level rise projections. That is being used for these main issues. How do we prevent an event from taking down our system or creating outages? And if we can't prevent it, how do we mitigate the amount of damage that has occurred? And then if that's even further, the next thing is how can we respond and turn things around faster, right? Those are our key focus points. So when the engineers are going through their design factors, this is where we're asking them, when you update your spec, so your new business, anything in the new business realm, will be designed based on this new criteria. So if you have a facility that you're going to put in place and it's got a 100-year lifespan, you have to make sure that the flood, if it's in a flood zone, that its flood protections meet the FEMA plus 5 numbers. If you're looking at putting in a major renovation of a site, the same thing occurs. You have to incorporate now these new numbers. There's cycle changes of equipment, HVAC equipment. As you cycle that stuff through, making sure that at the appropriate time, you have the right capacity in the system, depending upon the amount of heat that we're expecting to see in that period of time. So you cycle it in, you might not have to make that change today, but you have to prepare for it. And one thing that we've done in a building that was already in progress of being designed and built is we recognize that in order to upgrade the HVAC system in the future, you wanted to put a heat pump system in place. Number one, it's highly efficient, so that's one focal point. But the other side of it is that that system utilizes pipe instead of ductwork. So if you do have to upgrade in your capacity, it's a lot easier to change piping than it is to change ductwork. So you've designed the system that's it's adaptable going forward as well. And then there's always going to be some areas where maybe you can't get to it in time, or it's cycled in with a planned renovation that you have to now have maybe different operational needs in the interim. One of the things, the same facility, it's not built to FEMA +5, although it's a workout session facility. So the issue there is, if it does flood, you do have the opportunity to put in some flood barriers, sandbagging that just to keep the amount of floods down, because we're thinking maybe it's an inch of water. So you'll have to deal with that with an operational move whenever those events happen. These are the different things that we had. It's change management, working with them to try and make sure that they incorporate this. By having tables and a guideline was very helpful to them, because now they have a reference point to go to. And as we said, heat, flooding, extreme events, those are the key areas that impacted us the most. So what we were looking at is, these are the areas that we were most impactful. These are the things that we think we'll have to wind up doing. And this is stuff that was incorporated into our recent rate case, where transformer replacements, because ambient temperature is going to be higher at a sooner rate, you may have to, because the transformers now will age faster in that high temperature, you might have to change your turnover rate, or you have to design in understanding that you'll have some capacity issues or a risk of failure built, and maybe you have to put in additional transformer. These are the sort of things the engineers have to go through, and they have to ask us questions about how likely is it that we're going to see temperatures going over 86, right? The new data that we're getting from the newer models, so our past was on CMIP 5, the new models are the CMIP 6 models. We're getting that information in as part of this legislation. All the New York State utilities are using that data. That's showing that what we're expecting in terms of temperature rise or frequency of heat waves is moving earlier. So instead of something happening in 2050, we're starting to see it might be as close to 2040 that we're starting to see that same rise that we had expected in a number of heat waves going forward. So we're working with the engineers now to update, to rethink this, see if it has a significant impact, if accelerated impacts really are a problem, or if the way you've got it planned out, you've got it covered. That no matter what you do, you're doing it today, it'll be covered. Just like our sea level rise, our 1 foot of sea level rise covered us till 2040. Some of the work that they've done since then on temperature and precipitation and wind related may carry us further down the road, and the fact that it accelerates and the climate change isn't a problem. So I went through that pretty quickly, and I know that we have an opportunity to go through questions, but if anybody wants to go to our website, Resilience Plan, we have the whole package of the study that we did in 2017 to 2019, our implementation plan, how we built that in 2020, and then we've been keeping it up to date. You'll see a very rigorous plan put together in 2023. So November of 2023, we're submitting to the State Public Service Commission our resilience plan for 10 and 20 years, along with 4 other utilities in New York State. So there's a lot of information out there as to how we've gone about it, the materials that we're using, and then how we're applying it. I think I'll finish it there unless there's any other comments from Nelson.
All right, I'll take that as the end then. Thank you very much, Nelson and Charlie. Really, really appreciated that presentation. Indeed, delivered quite efficiently. So thank you for that. The point, especially about the interaction between your core management team and the external advisors, the consultants and the university, and the stakeholders in form of a working group, I think that's a really helpful lens to consider, especially utilities that are thinking about what kinds of institutional arrangements they may be able to adopt for incorporating climate change into their own planning and operations. Next up, we have Eric Kuhl of PG&E. Eric is a member of PG&E's Climate Resilience team. They work to integrate forward-looking climate projections into the company's planning and risk assessments, and they're responsible for completing climate vulnerability assessments. So take it away, Eric. Thank you.
All right. Thank you so much, Jonah. As mentioned, I am with Pacific Gas and Electric. We are a California utility. And today I was just going to walk through a few kind of core issues related to PG&E's climate resiliency program. First, just wanted to set the stage of kind of how we got here, how climate change has impacted some of our risk approaches, the development of our climate resilience program and strategy. I'll talk briefly about our climate vulnerability assessment, how it came about, the scope of it, talk about what that means to PG&E's approach to a programmatic climate resiliency program across our company, and then closing with just a brief discussion around kind of a key use case of just selecting the right or selecting a climate scenario for planning purposes. PG&E, we are one of the first climate bankruptcies, of the 21st century. Climate change is occurring in California. We have a Mediterranean climate out here, which means that even before climate change, it was a case of extremes in terms of temperature, precipitation. But now we're seeing increased heat waves, changes in precipitation, so longer, more severe droughts. We're already seeing the impact of sea level rise in the Bay Area. Wildfire risk is obviously very prominent in what we do and what the risks we're managing year to year here at PG&E. And wanted to also highlight here that climate change, not only are we seeing more extreme and frequent events, but it's really an important regionalization focus here. So for California, we see a different potential impacts of climate change than some of our other utilities. We don't have hurricane risks that New York faces, for instance. And so anytime you're kind of looking at the impacts of climate change, just an important consideration to look at the regional environment you operate in. We're not talking about new hazards that you'd be facing, but just more of a amplification of current trends that you're seeing in your service territories. This slide kind of details the risk journey. As Con Ed kind of mentioned, what we've seen, particularly when we've talked with other utilities, as far as climate resiliency programs go, a lot of it is started with a precipitating event, such as a major wildfire, hurricane, major heat waves, that really amplify awareness across the organization, regulatory and stakeholders, or other interested parties to develop kind of a more programmatic view of how to address these issues going forward. So kind of calling out in PG&E's case, Northern California wildfires in 2017, the Camp Fire in 2018, they really precipitated major actions around wildfire mitigation for PG&E. This we don't think is necessarily you need to wait for major events. There's enough science and understanding of climate change now to understand what the potential outcomes in the future will look like from a more extreme weather system. So it's more important now than ever to be programmatic and thoughtful of how to address the changing risk profiles rather than being reactive. And on the bottom, you kind of see this risk evolution here at PG&E. A lot of this is in partnership with our regulatory oversight at the California Public Utility Commission. And one of the things I really wanted to kind of highlight here is the quantification of risk and how that has occurred. Starting in 2014, we have what we call RAMP and SMAP, so the safety model assessment proceedings, the risk assessment mitigation phase. Both of these are, regulatory efforts that are focused more on, developing the tools to compare risk levels and make decisions based on that. And that work continues, and climate change from the early efforts is now more integrated into these processes than ever, so that when we're looking at risk profiles in the future, it's accounting for how weather conditions will be changing, how our climate patterns will be changing. This overall risk profile and change is part of an evolution of climate resilience initiatives here at PG&E as well. This is just kind of a quick snapshot of a few major what we would call climate resilience initiatives here at PG&E, and that's inclusive of some of our wildfire efforts. And so if you're not from California, some of this might not be familiar, but public safety power shutoffs, that's PG&E or other utilities being proactive to shut down power lines in the event of high wind conditions or severe fire threat areas to manage some of that risk profile. We've developed wildfire mitigation plans, vegetation management. Most recently, last year, we announced and rolled out enhanced power line safety settings, which the detailed graphic here shows, just being more proactive. Our CEO made a commitment for 100,000 miles of undergrounding. This is primarily for wildfire mitigation purposes, but undergrounding has the dual benefit of also helping to mitigate a lot of the threats and risks of other climate hazards. Our team has partnered with multiple groups across PG&E in 2021 to work with community stakeholders to apply for and receive a grant from the FEMA, Federal Emergency Management Agency, to develop a seawall around not only our substation, but a significant part of the community in San Mateo. And earlier this year, our CEO has led the release of PG&E's first climate strategy report, which details not only mitigation, but also climate adaptation investments. And then we're rolling out and planning for changes in not only the grid, but the climate through our integrated grid planning efforts as a major effort going forward. And underpinning that, since 2020, we've been working on our climate vulnerability assessment and associated community engagement plan, which I'll talk about more. And if you kind of look at PG&E's ecosystem of what's available around climate adaptation, mitigation, wildfire, we have four major documents that we'll be working on. Three of these are already public: our sustainability report, the climate strategy report that I mentioned. These are both public documents. We also have our wildfire risk management plan, which is, again, a public document that is filed with our regulators. Our climate strategy report kind of sets that framework of, the difference and accounting for not only climate mitigation, so emissions reductions efforts, but also details kind of some of the core components of how PG&E is building a more climate resilient energy system going forward. All these are out there and you can find for more information. And I think are really helpful to kind of set the stage. And one of the core benefits of the team, the work that we do within our team, is having such high level leadership support for these efforts. We know climate change is a major issue. We want to take proactive steps to address this. And this is setting the stage and the high level leadership buy-in to be proactive with our investments and understanding of these risks so that we're building that more resilient energy system. Our climate vulnerability assessment, we've largely completed the work and we're in the process of organizing this and doing our leadership reviews. It will not be filed until May 2024. That's not stopping us, though, from implementing a lot of the key lessons that we've already learned through this process, which I'll talk about. Kind of stepping back a little bit. So I mentioned I'm part of our climate resilience team. PG&E's approach to climate change risk management was to create a specific team really focused on this issue. We have a whole group dedicated to wildfire mitigation, very robust analytical tools and processes associated with that. That is one of multiple climate hazards. Our climate resilience team is really set up to look at not just wildfire threats, but all kind of climate hazard conditions that impact our operations. So right now it's a team of 4 of us. And we really have a mandate to not just work on our regulatory mandate, our regulatory focus of the climate vulnerability assessment, but to essentially become the internal experts on climate change across our company and integrate the learnings, the data, the science that is available across our organization into how we plan for and adapt to the climate future. And this was done largely because this is a very complicated subject. The science is constantly evolving, and it's not realistic to expect each group that has to deal with climate change issues to be an expert. So we have a dedicated resource within our team to work across our organization to provide that expertise to understand, what climate data set is maybe most appropriate. What is the information that's actually available? What does it mean? What are some of the tools that are being developed to better understand this? And so we report up through systems and resources planning to our engineering planning and strategy group. This has been an evolution. The climate resilience team initially started as part of the corporate sustainability group as they were developing some of those climate mitigation plans and efforts, and has since been spun off to work more closely with the core groups that we work with, primarily in the engineering side of our business, so that as we're planning for future investments, we are partnering closely with them to integrate our data, their climate data, and projections into that type of work. We still work closely within corporate affairs and the sustainability group, as well as partnerships with our enterprise and operational risk management team, so the risk professionals within our group. Climate change is occurring, and we're seeing the impact of that on extreme events. So we partner with our emergency planning and response group to better understand the range of potential extreme weather events that are occurring or expected to occur over the near term, and meteorology as well. And climate change is considered a cross-cutting risk factor here at PG&E, which means that we do have board oversight of our efforts. We report out to the board annually, the Sustainability and Governance Committee, to provide an overview of what that risk profile looks like, what our regulatory strategy is. And operationally, we report out kind of on a daily, monthly basis through our organizational structure to our EVP. Next here, just kind of talking about our climate vulnerability assessment. The methodology for these is pretty well understood and in the public space. And I just wanted to kind of highlight a few key issues here that are California specific. So PG&E did its first climate vulnerability assessment in 2016. This was not a mandate. It was a proactive step that PG&E made. This current effort is part of a climate adaptation decision from the California Public Utility Commission for all the California utilities to complete a vulnerability assessment of the infrastructure, operations, and services within the state. This does not include overall energy system operations. So it is not inclusive of everything that PG&E does, but it's really looking at what assets that PG&E controls and the business processes PG&E controls by itself. We include climate change projection, sensitivity, adaptive capacity, to really understand what that future risk profile looks for PG&E. This was done on a quantitative basis using geospatial analysis to develop a qualitative risk assessment rankings. And our regulators really asking the California utilities to do this, to take that step back and look at how climate change, what is the full breadth and impact of climate change on future energy assets, in order to really prioritize what are the areas that are going to be most impacted, what are the highest risk areas. So it's really a risk prioritization exercise over the long term, so that proposed adaptation projects can be developed. And one great thing about our OIR decision is this community engagement aspect of it. We are working with local community groups across our service territory to understand how climate change is impacting them now and expected to in the future, take some of the feedback from those community groups and integrate that into our understanding of the issue and potential scope of responses that can be made in the future. So in addition to the climate vulnerability assessment, PG&E will be also filing a community engagement plan in May of 2023. That is part of this overall effort that our team works on. And the full results of that will be available later in 2024. So we see that climate vulnerability assessment is really being that foundational piece of our work to understand how climate change will impact PG&E's operations and assets. What that means then is we have a better understanding of the science, the potential results of that quantified look at our assets and the overlay of climate hazards. And we're using that information to really develop a strategy around how to integrate some of those learnings and key lessons across the organization. We have multiple different verticals, as we call them, where we're working towards that effort. First, kind of calling out our action plan for electric and gas generation groups. What this means is that we're partnering with some of the asset management owners to who coincidentally were a lot of the subject matter experts that we interviewed as part of our climate vulnerability assessment process to understand the risks. And we're talking with them, providing the feedback back on the climate vulnerability assessment, providing additional data of what those climate hazards look like, so that that is now part of the asset management planning process going forward. Another key effort for PG&E is design standards. So one of the most cost-effective and we think no regrets approaches for becoming more climate resilient is ensuring that as new equipment goes in, it's being designed for these future expected range of weather conditions and extreme weather events. So we have an effort dedicated to working towards identifying some of the most impactful design standards for our equipment and partnering with those engineering groups that own those design standards to scope out what a update to those would look like, some of the impacts of that, what are the relevant factors that need to be considered. And these can be things from, as Charles mentioned, like raising our expectations of sea level rise so that when we're putting in new equipment, it's sized out properly for the expected range of sea level rise outcomes and storm events, to temperature maps for new transformer equipment, and other types of investment situations such as that. Another key effort that we're taking is integrating climate data into our risk models. We've kind of mentioned we have an increased quantification of our risk processes so that when we're making decisions on mitigation investments, we're able to kind of compare apples to apples. We've integrated long-term projection data to better model out how risk events might change, as a result of changing climate conditions. So higher temperatures, can lead to different types of asset failures. That's something we want these models to be reflective of. Changes in precipitation patterns, increased risk of fires, debris flow post-fire. These are all types of issues that we know are going to become more exacerbated in the future and need to be accounted for in the planning process. And speaking of planning, another kind of core component is integrating long-term projection data sets into our long-term planning for things like load forecasting, and just understanding how climate might impact changes in future conditions. And we already see this internally here at PG&E and across other orgs, is that a lot of the forward projection data sets are already including climate change to some degree. So we're not talking about reinventing the wheel here. What our team is more focused on is really just providing that expertise and asking the questions to our groups that are working primarily with, maybe regulators or data providers to, ask those questions around what type of forward-looking data, is being integrated in. Is it consistent across the organization? We don't want to be planning for different, futures based on which group owns that forecast. And another kind of core component of what we do is working with our community needs here. And so we have a lot of kind of within those major verticals that we talked about, we have a lot of different focus areas, short and long-term planning. And again, one of the things I just kind of wanted to call out here is our integrated grid planning effort. This is PG&E's efforts to more systematically plan over the long term for our changing energy system. we expect the grid of the future to be developed, more electric vehicles, increased DER penetrations, battery storage, a shift from GHG emitting sources to more clean energy sources. All of this is occurring at the same time that we need to build a more climate resilient energy system. And in order to do that cost effectively, it really takes this more integrated plan approach that's going to systematically look at investments over a longer time period than just planning year to year. And what we're really targeting is, to systematically account for the physical risk of climate change and how we plan, invest, and operate our energy system of tomorrow, so that we're being responsible with our ratepayers' money as we kind of continue to invest in the future. And lastly, I just kind of wanted to talk about an exercise that PG&E has gone through several times here internally of just integrating climate data and projection data sets into what we're doing. So we are using the RCP 8.5 in our climate vulnerability assessment. This is a mandate from our regulators to use the RCP 8.5 within risk proceedings or risk assessments. What that means, though, because there are so many different ensemble models with that, is you have actually a pretty wide range of outcomes that you can select and design for. And this is just a, not a straightforward, way to pick a future. And it really takes a thoughtful approach to understand why you're using climate data sets and what some of your desired outcomes are for. So in this case, with our climate vulnerability assessments, these are risk processes and efforts. In that case, we want to be very risk averse. We want to plan for a more extreme future scenario in order that we build that more resilient energy system. That is not the case for things like long-term planning on load forecasting or design standards. And for each of those kind of considerations, we would recommend that you go through kind of a process of engaging with your subject matter experts that are going to be affected by these changes, your leadership teams, to kind of highlight what some of the potential outcomes and impacts would be of different selection choices. So here we kind of have a few, just brief examples of if you pick a 90th percentile versus a 10th percentile, what are some of the planning considerations that would be impacted by that from a temperature perspective or precipitation perspective? So you can, within a global climate scenario, the RCP 8.5, you can see a pretty wide range of outcomes for what you select. Are you selecting some of the more extreme outputs from the ensemble models, or are you taking kind of a more median approach? And this is just a, kind of thoughtful exercise. PG&E is taking our case-by-case approach. So when we kind of make these decisions, we're meeting with, various stakeholders, kind of outlining what some of the impacts of selecting maybe a more risk-averse scenario versus one that maybe is considered more likely or plausible from a climate model output selection there. And with that, I can turn it back over to Jonah.
Thank you so much, Eric. Great presentation. Already thinking about a lot of the lessons learned from both utilities that you've shared with us. Clearly both organizations have decided that they need specific teams dedicated to climate resilience. Like Eric was saying, you can't expect every engineering group or other part of the utility to be experts. And so it's interesting to see that both adopted a similar structure. There's also the point about proactivity versus reactivity. Major climate events, extreme weather events really propelled change in both organizations. But like Eric pointed out, there's not necessarily a need to have to wait for that kind of event. We understand the climate science enough at this stage to get a head start and try to fortify power systems against climate-related threats. And then finally, the point about integrated grid planning and community engagement is really interesting. I think that's probably what the future holds in terms of utilities not only meeting demand, but also bolstering resilience at the community level. Those are just a couple of the lessons, but I should mention that these presentations are going to be distilled into case studies with developing country utilities in mind. And so you can expect those coming after the new year. Now it's time to transition to the panel discussion. I'll invite all of our panelists to come off mute and also turn on their cameras. In addition to Nelson, Charlie, and Eric, we're joined by our panel moderator, Dr. Mikhail Chester. Dr. Chester will be facilitating a discussion between the utilities, helping contrast their experiences, and leaving the audience with key takeaways and some food for thought. Dr. Chester is the director of the Metis Center for Infrastructure and Sustainable Engineering at Arizona State University. In that role, he maintains a research program focused on preparing infrastructure and their institutions for the challenges of the coming century. So a very appropriate subject matter expertise to lead this panel. His work spans climate adaptation, disruptive technologies, innovative financing, transitions to agility and flexibility, and modernization of infrastructure management. We're very grateful that Dr. Chester was able to step in at the last minute to fill in for his colleague, Dr. Nate Johnson, who you may have seen on a lot of our other webinars. And as we transition to this discussion, before we get started, I'll ask USEA to just kindly open up the poll. We have a couple of really simple questions for our audience, asking really whether you're currently implementing any climate risk management practices, and if you're interested in following up with AMP Up on anything that you've heard today. The Q&A feature, I understand, has already been enabled in the chat as well, so feel free to ask any questions of the speakers. Dr. Chester will either select some of your questions himself, or I can forward those to him as the discussion proceeds. So that being said, I'll forward to Dr. Chester and looking forward to an engaging discussion. Thanks, everybody.
Great, thanks, Jonah, and greetings all. Delighted to be here with you this morning. It's one of the 10 days a year or so when it's actually raining outside in the Phoenix metro area, which is a nice reprieve from us. So let me kick off some discussion here. First off, I'd like to thank Charlie, Nelson, and Eric for the excellent presentation and review of the kind of innovative approaches that these two organizations are doing. So as a reminder, as Jonah just said, we have a Q&A feature at the bottom. And if you hear them say anything, or if there's anything you have heard already, please pop in questions, which I will then pass along to the speakers. So to kick us off, for Con Ed and PG&E, there's a question here that is around the tensions that might exist in your climate group's goals, the organization's fiscal goals, and any of the engineering team's goals. So have you guys experienced any of this? How have you dealt with it, and so on?
So this is Nelson, and I would say it's not necessarily a tension. As we always say, resilience is a shared responsibility and a shared goal. I think it's really important that, as we mentioned here, that we all want to head to a clean energy future that includes understanding the impacts of physical climate change. So in a way, from our external stakeholder to our junior designer to our CEO and our board, we really are aligned in terms of making sure that we withstand the impacts of climate change, that we continue to advance on not just safety, reliability, and operational excellence. We really have to think about how resiliency is a big part of all the things that we need to do moving forward. And then the other piece is, as we mentioned, it's as we're picking our pathways based on the data that we see, we want to make sure that we engage with our stakeholders, as Charlie mentioned, our stakeholder working group, which includes municipalities, which includes the Department of Public Service in New York. And it's really engaging in that conversation along the way, so that when we file our long-term plans, which are incorporated into our rate cases, there has been a robust discussion about that, and also about costs and value of the things that we're doing.
Yeah, and I would say that, again, we don't see necessarily a tension between goals. We have, strong leadership buy-in from, our CEO to our EVPs that this is an issue that needs to be addressed. We've had the experience of of already dealing with climate hazards on a kind of day-to-day, basis here at PG&E. But what I would say that we see is that there is just limits to what some of our groups and partners within can plan for in the long-term sense. There's so many kind of immediate needs that need to be addressed. And so that's why it's helpful to have kind of a core team dedicated to the subject that's kind of continually talking about the issue, providing the data, making it easy for groups to consider these types of issues in the planning. And part of that reason I think the tension isn't really there is that by being proactive with climate change, in a lot of cases, you might see more upfront investments, but if you're not planning for these conditions, you are going to see larger costs down the line from recovery and repair operations versus being proactive in the investments in the first place. And that's been a kind of a core component of our strategy of just trying to find these initial solutions where it's kind of a win-win scenario versus just not doing anything about what we know is a major issue that's impacting our orgs.
So Nelson, Charlie, and Eric, let me follow up with one additional question on that front in terms of kind of organizational leadership. What if there is none? You guys are in two fairly innovative organizations around this topic. For the attendees here and the broader public who might be interested in this topic, what if you're in an organization where strategic leadership is not totally on board or totally willing to prioritize climate adaptation? Where do you see possibilities where the organization could make some movement there? How would they go about doing it, again, if leadership is not necessarily proactive about it?
Yeah, I didn't really mention this, but there's really no easy answer for that question. But I think one of the things that I've noticed in just even the last 6 months is who's interested in this subject has changed pretty significantly from a public perspective. We're in California, our regulators are very interested in the subject, but more recently, we've also seen efforts from shareholders focused on this issue, from green bonds to sustainability funding. And raising those types of issues to leaderships, I think, would be a helpful avenue, as well as federal regulatory oversight of the issue or disclosure of this issue is becoming more prominent. So even if there's not existing leadership awareness of this issue, at least within the US context, there's so many different efforts moving forward. And I think it's very, what I would recommend is also looking at the win-win solutions. At least here in the US, there's a lot more federal funding available for resiliency efforts, a lot more partnership opportunities, not only with other utilities, but with other stakeholder groups, and focusing on those types of broad level efforts to highlight the importance and changing nature of this position or this issue going forward.
And I would say, I'm going to turn it over to Charlie soon to talk about it, but when we started our vulnerability study for the first time, we made sure that we get the people who are the designers, who are the people who are the implementers, to really understand how we don't just use historical data and how do we think about using future data. So you're correct, Dr. Chester. It's easy to think about safety. It's easy to think about wetlands and the environment, but it's getting even the people from bottom up and our engineers to understand where this data is leading and really thinking about it in terms of risk. I think that is an important, data-driven decision. Charlie?
Yeah, and I'll go back to the fact that having external participation, getting that external pressure as well. We had a very active working group that, well, actually it started off as a collaborative, but even as a working group, very active participants who on their own put pressure on our organization in different levels to say, we want you to address this. And so it wasn't just that us, an event starting it, which got everybody's attention, but also the fact that all the different parties involved, internally, the engineering groups, when they had to solve the problem, the external groups that were looking for solutions on their end, because we are a critical service to them. They can't do things without electricity. So they have to be very concerned that we're addressing the climate changes. And they made sure that we stood up and answered questions about where we were going and what we're doing. So that was very integral to have them involved. And then because of that, we had corporate executive team pulled together to make sure that this is followed through. And our CEO was on with it as well. So it all blended together as time went on. Everybody's participation helped solidify the approach that we were going to take.
Perfect. Thanks all. We got a few questions here related to kind of technical design, and let me try to kind of bundle them together and kind of elevate the discussion for you all. How are you guys planning for both gradual change as well as extreme events? Do you do it the same way? Are there different approaches that would be used? And then how do you deal with kind of the situation, Charlie, I think you mentioned in your presentation, of kind of uncertainty that might translate to design uncertainty in climate models that translates to design uncertainty, and ultimately, this idea of, how big do you design? How robust do you make it? Can you afford to make it, to RCP 8.5 all the time? Or, is there some other approach that's used?
Yeah, so I guess a lot of it has to do with the fact that the climate science really can't give you firm numbers on extreme events. That's always going to be a weak spot on the climate science. They can tell you that more intense, frequent events, and we're seeing that. So they can say that, and that it's agreeable, but it's a judgment call on our end to take, okay, here's where new normal technically is going to be. So that the climate data that we're getting, people don't like me to say this, but it's kind of like the new normal. You're going to be operating in a hotter environment. You're going to have more heat waves. It's going to be over 95 degrees, like for a third of the summer. And, you have to be prepared for that. And along with that comes the fact that that encourages events to happen that we haven't seen in the past. We may see a stronger hurricane coming up this level. If we designed to a Cat 2, maybe it's a Cat 3, maybe it's a Cat 4. These are the sort of things that we still don't have firm quantified information from climate science. So it is a judgment call. We have qualified data that Columbia University is providing to the entire state about where they think climate science is saying that the events are going. We have some information on like heat waves, because temperature is something that the models put out pretty well. So we can get heat waves going and have a sense of how frequent, how hot they'll be. But when it comes to a storm, we're still working through. In fact, we have to do additional studies on wind and deluge rain because those are weak spots in the climate science.
Yeah. So for extreme events, like kind of the example here in California is our wildfires. We've developed very robust analytical tools to look at utility caused wildfires, understand the conditions that are going to precipitate that, and we're making proactive changes to our system to mitigate those types of risks. Some of the other science around extreme events, just we don't have the necessary understanding yet to model that out, or the analytical tools for what those impacts look like. We are partnering with our EP&R group to better understand the range of potential outcomes, but this is kind of a work in progress, a moving average, a moving kind of range as we go forward. What we've done is just providing kind of that view that Charles mentioned of like the operating environment for our assets is going to be changing. And as we start putting more investments in the ground, like those need to be designed for those types of conditions. It's going to change your expected asset lifetimes or your failure rates. So let's design them more robust where they need to be so that they're going to actually meet the expected lifetime. It's just, it would be great if we knew what the next major heat wave would look like. In the absence of that, all we can do is kind of provide more information to our partners across the organization that these are just be more likely, so that as we go forward, we are investing kind of in a way that's more proactive.
And I might add to that, one of the things we're looking at is if an event could happen in Texas or in Florida, doesn't mean it can't happen here if the conditions are right. So we're looking at these events that are happening and saying these could establish some of the extremes that we may have to look for. Harvey dumping, tons of rain over a 5-day period was, damaging. Is that possible here? It could be. Is that how we set our standard? So we're looking for stuff to help us support those decisions, but we are looking around and saying, we had 10 inches of rain within 7 hours, only 50 miles away from New York City. So if that can happen there, why? Just the fact that it didn't happen here is timing, where a high or low pressure was. So we're trying to use that as guidance on how we would look at extreme events.
Perfect. Thanks, all. So let me ask Eric. You were talking about asset lifetimes, and we got at least one question there around, how do you think about, what has normally been viable to do, a very long-term asset, maybe a centralized technology like a generator. Whereas, now you've got climate uncertainty confronting, the normality of what we've assumed to be, reasonable in the environment, and allowing us to build these very long asset lifetimes. Do you see a model where you guys are kind of adding flexibility to the system by reducing asset lifetimes? Do you guys find yourselves, and this is for both organizations, maybe advocating for other types of technologies like microgrid that might, give you some of that flexibility?
So I would say, as far as the resiliency journey and adaptation planning goes, we're not there yet where we've made some of those clear-cut decisions. That's why we're focusing on these kind of no regret solutions first, and that would be kind of our recommendation. Like, you can't tackle this entire problem all at once. You've got to kind of work through the org and understand the core impacts. And for us, that's why design standards were one of our first efforts that we're making. So that if you're looking at these long-lived life assets, that you're looking at the 2050, 2080 operating conditions that they would be facing, and you're working with your engineering partners to, update those standards so that the equipment isn't going to see a more accelerated, asset failure rates or asset lifetime. And can you go back to the first part of your question? Sorry, Mike.
So I kind of asked two things. One was related to kind of asset lifetimes, and this idea of kind of shrinking asset lifetimes, or maybe using different technologies was the second.
Oh, on the microgrids, yeah. So we're in a case too here in California. Our regulatory framework. We have a separate kind of effort focused on microgrids. That's not part of the climate resiliency solution set that we're developing. Microgrids I think are a great tool to protect and bolster specific communities. Right now, and as far as my team's effort goes, we're working on kind of the more holistic energy system and building resiliency of our assets first. And there's a whole separate proceeding that's focused more on microgrids from a community's perspective. And so it's not using microgrids necessarily as a tool just for climate resiliency unto itself, but there's a whole separate process focused on that here at PG&E.
So I might talk about, for asset life, this is one of the things, by giving the engineers some indication of, so if ambient temperature, which has an impact on transformer lifespan and possibly on rating, they can anticipate how they might keep that lifespan going by introducing cooling to the transformers earlier than they expected, so that they can carry this transformer a little longer. Or they have to look at a replacement cycle and saying, well, we're going to assume that based on the temperature that it's going to be exposed to, that its life cycle has to change. Or you can design in additional equipment to take over the fact that you may have a failure, but you'll have a spare transformer now, instead of relying on a certain set of maybe 2 transformers. Maybe you have to have 3. And it comes down a lot to the economics of each of those solutions, and what is acceptable to your stakeholders, and what they think is an appropriate way of going it, and they have to understand the risks involved if you don't make some of those investments, that you may be exposing yourself to outages. We're trying to avoid that, but we understand you pay now or pay later becomes an issue.
One of the dynamics that we like to think about in our research is this idea of a decoupling between how quickly climate is changing and how quickly an organization or the technologies that they're using are able to be pivoted to meet that change. And often, we like to think about lifetime from this context of, if climate is changing very quickly, then it may not make sense to invest in technologies that are really rigid and can't change as quickly as the climate is changing to be able to function as you need them to function, which then sort of opens up this window of questions around, what are the technologies that are able to make those pivots happen quickly? How do you do dynamic planning to kind of implement those technologies as your perspective and the science on climate improves?
Yeah, related to that, Dr. Chester, it's also thinking about more sensors on the network for the resilience. And then also, with all the utility investments in advanced metering infrastructure, how do we leverage that data for response and recovery? How do we think about making that easier for our planners and operators to also design with that in mind in terms of the recovery? And then you're right, in terms of technologies, are there technologies now that can be utility grade to go on our systems based on cybersecurity and other concerns? And then finally, just really thinking about, we are focused on a lot of the storm hardening, but then also the engineering pieces are really, can we get more of the healing properties of the overhead into the underground? But then in the last, related to the last question, it's thinking about emergency response and preparedness. Until we upgrade a whole storm harden, a vast part of our system, we also have to invest in emergency preparedness to make sure that the recovery for our customers comes back in a timely manner.
And that's why we have that, approach of prevent, mitigate, respond. You try to prevent where you can. If it can't, if it's too rigid, as you say, then how do you mitigate the impact? And then if you can't even mitigate enough of it, then how do you respond faster? Those are factors in the decision process.
Great, thanks all. So a few other questions that I'll try to combine. So, I'll give the background that I grew up in Connecticut, and actually Windsor, Connecticut, which is arguably the oldest town in Connecticut, 1633. And I remember growing up seeing overhead or above ground distribution lines, and that was normal to me. As I've moved out west over my life, and particularly in Arizona, it's very difficult to find above ground power lines. Everything is below ground because the infrastructure here is fairly new, relatively speaking. So a couple of questions that have come up from the audience. How have you estimated how long it would take California or New York City to meet the level of Germany or the Netherlands in terms of buried electricity infrastructure? And then do you see key transmission lines and underground cables, Nelson, to your point, now having temperature sensors, or is there sort of integration of temperature sensors or some sort of sensing along the route to give us new perspective on how those lines are performing?
Yes, I could take an early one, not for California, but for New York. I would say since we are one of the most reliable utilities in the U.S., based on our over 94,000 miles of underground cable, to be able to do that in a systematic manner and an orderly way, it's going to cost a lot of money. So I think we've started thinking about a targeted or selective undergrounding program with pilots in the last year, 2 to 3 pilots this past year, to see, what are the benefits, how can we enable some of these areas which have seen more overhead impacts, and then how do we make sure that we get some lessons learned from undergrounding. And as Dr. Chester has said, there is a large cost to some of the undergrounding moving forward. And then we also have to work with our stakeholders who, if we had to update, they would also have to update their equipment. In terms of everything that we need to do, it would be many, many, many years over, 20, 30, 40, because we have such over 90,000 miles of underground cable. It would make more sense to underground strategic areas that have been impacted by storms or overhead areas, to make sure that we, have to do what to protect the over 40,000 areas of overhead areas moving forward. Eric, do you have anything related to PG&E?
Yeah, well, one, I can't really answer that question. I'm not that familiar with what Germany's and other countries have been doing on undergrounding, but from just PG&E's perspective, I think it's well known. We made a commitment to underground 10,000 miles of transmission lines in 2021. That's going to ramp up from roughly like 140 miles a year to over 1,200 miles a year by the end of that 10-year commitment, kind of meet that goal. This is done very strategically to focus on the 10,000 miles of our lines that are in the most high fire threat or in the high fire threat district areas, which are the areas identified by the state as being the most susceptible to major catastrophic wildfires. So from a strategic standpoint, like, it is to focus on areas of the highest risk for our undergrounding programs in the near term. What we're seeing is there's a lot of ancillary benefits for just overall resiliency from our undergrounding efforts, which we think are going to save our ratepayers money over the long term. We had a major winter storm last year, and it was estimated that up to 90% of the outages would have been prevented if those lines had been undergrounded. So it is not just a wildfire, only mitigation solution. It is, something that builds increased resiliency across our organization. And the way our leadership has framed it and is looking at this as, from a cost perspective, it is potentially more expensive from an upfront investment standpoint, but holistically, when you look at the operating expenses, our veg management programs, undergrounding, over the long term looks to be more appropriate for our ratepayer money to build that resiliency in the energy system today, and defer the need for just that constant maintenance expenses to keep our systems running smoothly.
Thanks all. One of the things that strikes me about power systems, which is very different than, say, water distribution, transportation, is, climate has, particularly heat and cold, but has direct effects on both the supply and demand side, right? You're hard pressed to find that same dynamic, at least exacerbated on the kind of water and transportation side of things when we think of infrastructure services. At the same time, you're seeing lots of technology, particularly connected technology, smart thermostats, I'm thinking of in particular, come into play. And I'm wondering, you guys spoke a lot about the supply side of things and, preparing, hardening on the supply side. How do you see yourselves sort of integrating with the kind of demand management side of things, whether it's you guys controlling demand management when it comes to climate extreme events, or maybe a third party coming in like Google, Nest thermostats controlling demand management?
That's an
Demand management, something that you're thinking about?
Well, we look at smart meters and that as helping us better understand where the load is, where the impacts are, when restorations have been completed. We're using that sort of information more. We do have a demand management program. I'm not as deeply involved in that to explain how we would use it. I know that we've set that up. Even in our steam system, we did a pilot system on demand management to try and make sure that we can level out usage. Whether that's done internally or externally, I really can't speak to it.
Yeah, that goes a little bit beyond what my area of expertise, what our team works on. But I know that in the September 2021 or 2022 heat wave that impacted California, there were a number, it was roughly 9 days of alerts for energy conservation. And the state made one text message or emergency request, and they saw up to 5 gigawatts of demand response from that effort. So this is kind of a more you are seeing more interconnectivity with consumers and their choices and being able to reach them in a more efficient manner. And the state is looking at ways to kind of more systematically, understand what that demand response profile is for the integrated, grid planning efforts to look at overall capacity market or the overall capacity levels. And PG&E, I think, is very supportive of those types of efforts.
Thank you. So we have got about 10 minutes left, and I want to kind of pose one concluding question to give you guys a chance to, both organizations, to offer your kind of perspectives here, given the conversation that we had. So what have been the greatest challenges and obstacles on your resilience journey, and how are you working to surmount them?
I have to say it's an understanding of the climate science and working with climate science to produce information and data that we can use. That was the biggest challenge for us, is getting to understand what they can and can't do, being able to translate, our needs into, their capabilities. That was the biggest part. And then it's still, we still have this open area with extreme events where we're trying to fill the gap with other information as much as we can. And that's the other challenge.
I would add to what Charlie is saying. I think from a leadership standpoint, we had a lot of robust engagement and involvement, as well as down to our engineers. But it really was a change management effort with any large scale change. If we wanted to incorporate it into our company, we had to continue to provide awareness, engage, and have people understand impacts moving forward. So I think it's the constant communication needed. And then the other piece is really just having people understand the frameworks, and that there's lessons learned out there. So when I started, I think, and even when Charlie started, not a lot of utilities were doing vulnerability studies or plans. And so it's really thinking about building that network, understanding what other people are doing, and even like this, having AMP Up and then the program and the consortium really providing the robust case studies and the robust interactions and these webinars really does help surmount some of these initial challenges. If you are thinking about it, there are other people thinking about it as well. And it's really, how do you make sure that you use those resources to really engage and understand, and then really ask those really good questions moving forward.
So from my perspective, I can say in California, we've been very lucky that the climate science was provided to the utilities through CalAdapt, which has provided our downscale climate data. So PG&E recently hasn't had to go through the same kind of experiences of creating this climate data sets. That's kind of helped significantly in kind of moving this forward internally. Some of the challenges, though, I think, are just the organizational capacity to just constantly respond to changes or change planning practices. This is a moving issue. Most of our partners are already so busy meeting just regulatory commitments, 1-2 year planning cycles, that they don't have the capacity to just uphold and change, and plan for the long term in a systematic way. So one of the challenges that we faced is just finding, where within the organization to focus efforts on to have the most impactful changes. And two, I'd kind of say, is just the regulatory constructs. PG&E, any regulated utility can't make, investment decisions without consulting with a large number of stakeholders and going through kind of a, significant planning processes. And so just understanding that and having kind of the regulators buy-in or understanding of how these issues are going to change and require different investment strategies going forward, I think is also an important consideration.
Terrific. Nelson, Charlie, Eric, thank you guys so much. Just some sort of concluding thoughts here as I kind of reflect on what I heard today and think about what the key factors are that have led to or opened up some of the innovation that your organizations have done, which I think is truly remarkable. The first is leadership buy-in. I heard that come up a lot. that you guys have from the top down, from this CEO or from the board, folks who are, not only on board with climate change or accepting of it, but are actually proactive in implementing it. And also the organizational capacity that has to happen at the lower levels or middle levels of the organization to actually make that happen, whether it's the front line, middle management, and so on. Another thing that I heard frequently was the use of climate science, which is not a small thing to do, right? You've got these climate models, CMET5, CMET6, as Charlie was talking about, which are massive, hundreds of terabytes sort of thing. I mean, just to make sense of them often requires, a PhD. But you guys have found a way to make that work either with partnerships. You had mentioned university partnerships, and Eric had mentioned the work of and model data of CalAdapt that the state has made available, basically taking really complex models and making them usable, which is something that not every state or agency necessarily has at their fingertips. The sort of examining of design standards came up, which I think is one that many of us can relate to. Often you kind of inherit legacy design standards that are rooted in ideas of what the environment is or what normality is in the environment that come from 50 years ago, 70 years ago, something like that. And that's quickly being upended. So the question then becomes, how do we modify design standards? How do we modernize design standards given this climate uncertainty? And I heard discussion of both preparing for extremes and preparing for gradual change. And, I think that doesn't necessarily happen in the same way. There is some overlap, but there are some differences in how you would do that. Another point that came up was the innovative use of technologies, questioning, technologies that have very long lifetimes, opening up new technology implementations, whether it's sensors, microgrids, something else. A common point that you all said was this sort of public and stakeholder engagement and planning processes, this idea that the organization shouldn't just necessarily railroad ahead with something. This has to be a two-way dialogue between communities and stakeholders to make it happen. I thought that was an excellent point that you guys brought up. And the last point that I heard, kind of frequently brought up was this idea of knowledge transfer. Whether it's through webinars, engagement with other utilities, what have you, but this tends to be a really important one. We don't all have to invent the wheel every time we do it. There's an opportunity when somebody figures something out to talk with somebody else and basically say, how did you do it? What can we implement? What are the similarities? What are the differences, and so on. So again, thank you all for sharing these experiences, and kudos to kind of these efforts, and I'll pass it over to Jonah.
Thank you very much, everybody, to all of our panelists. You made very insightful points all the way through, and we're really fortunate to be able to have all of you here. Now, this is the point where a lot of people will sign off of a webinar, but if I could just have everyone stay for another minute. We want you to remain engaged on these topics and with our AMP-UP program. We're going to be hosting more webinars on climate risk management and other subjects come spring. We're going to be disseminating the key lessons and case studies and publishing those. And in the years ahead, we hope to even deepen our engagement on these issues by supporting utilities in developing countries with climate vulnerability assessments and adaptation plans. So with all of that in mind, we encourage you to stay engaged. If you want to be added to USEA's listserv, just shoot USEA an email. And feel free to reach out to Kristen Madler, who you heard from at USAID, to learn more about AMP-UP's technical assistance offerings. Before we wrap up, I want to thank USAID for sponsoring this webinar and especially acknowledge the pioneering work of both Con Edison and PG&E, without whom we would not be able to have this discussion. This session has been recorded, so we'll be sending out recordings to you via email in the coming days. It's also going to be posted on USEA's website. So if there are any colleagues you think it'll find interesting, we encourage you to share it with them as well. Thanks so much again for attending, and neglected to mention Dr. Chester again for coming in and saving us, serving as the moderator at such last minute notice. So we wish you a great week, and thank you very much for attending. Thanks. Cheers.